Greatest common factor and polynomials in factored form. So what does factoring mean? Factoring means breaking something into pieces, breaking a polynomial into the pieces that were used whose product is that polynomial. For example, if my number is 12, the factors are 3 times 4. In the factored form, 12 can be written as 3 times 4. And it can be also written as 6 times 2. It can be also written as 12 times 1. Ideally, we want to write the prime factors. So we want to actually go ahead and break it into prime factors. You might have seen the prime factor tree in the earlier grades, 3 times 4, which is 2 times 2. So I can say it's 1 times 2 times 2 times 3. That is a prime factorization for 12. So these are the factors and 12 is the product. Okay, and also we saw when we are multiplying polynomials, we've seen the foiling. When we're multiplying polynomials, we can FOIL first, outer, inner, last, and get to the product. So now we are going to start the process of breaking a polynomial back into its pieces. Okay, we wouldn't do the quadratic polynomials in this section, but in next section we'll focus on factoring the quadratic polynomials. In this section, our focus is greatest common factor and solving polynomials in factored form. Okay, so when you write a polynomial in the factored form, the order of factors does not matter because multiplication is commutative. So for 12, if you break it into 3 times 4 or 4 times 3, those are both the factors of 12. And multiplication is commutative, so it doesn't really matter which one you write first. When a polynomial cannot be factored, it is called a prime polynomial. Not every polynomial can be factored. So if it's not factorable, we would say it is prime. Okay, let's start with the easy numbers to find the GCF, because our first goal is to find the greatest common factor of a polynomial. GCF. How do you find the GCF? First, do the prime factorization of each number, and then find the product of all the common factors. That is going to be our GCF. For expressions involving variables, GCF is a product of all the common variables raised to the lowest exponent. Okay, we'll come back to it when we deal with the variables. For now, we have a couple of examples with the numbers. Okay, example number 1. So for 28 and 40, we want to find the greatest common factor. To find the greatest common factor, we're going to do the prime factorization of 28. If you like, you can make the factor tree, or if you just know that 28 will break into 1 times 2 times 2 times 7, that will be the prime factorization of 28. And for 40, prime factorization will be 1 times 2 times, that's 40 times 10, another 2 times 5. So to find the GCF, all I have to do is bring down every single common factor. So bring down every single common factor and then find the product of those. So I see there's a 1 in each of those. Another common factor is 2. Another common factor is 2. And that's all the common factors. So GCF of 28 and 40 is 4. Okay. Next example, 12, 16, and 40. For 12, 16, and 40, let's go ahead and do the prime factorization. I just did for 40, so I'm going to copy from the previous example. For 16, it's 2 times 2 times 2 times 2. For 12, I'm not writing 1. You can add 1 or you can skip 1 because, let me go ahead and add 1s as well. So 12 is 1 times 2 times 2 times 3. 16 is 1 times 2 times 2 times 2. 40 is 1 times 2 times 2 times 2 times 5. Now it is time to write the GCF. And we just talked about GCF is a product of all the common factors. I see a 1 is common, a 2 is common, another 2 is common. So 1 times 2 times 2. Again, the GCF is 4 for 12, 16, and 40. That means the greatest common factor in 12, 16, and 40 is 4. Next, for example number 3, we want to find the GCF of a to the third, b to the 7, a to the 7, b to the third, a square bc, a to the 4, b square c square. Let us focus on what did we say. If we have variables, For expressions involving variables, GCF is a product of all the common variables raised to the lowest exponent. Common variables raised to the lowest exponent. So what are the common variables here? I see there's A in every term. There's B in every term. What's the lowest exponent for A? Looks like A to the second power is lowest. What's the lowest exponent for B? Looks like just a B to the first power because that's what I see here. And C is not a common factor in every single term, so that's why C does not come down. And that's the GCF of these four terms that have variables in there. Here's example number 4. Find the GCF of 36 and 90. Go ahead and give it a try. Pause the video for a minute. Come back and check. So for 36, pause the video, try these 3 problems, come back and check your GCF. Up 1 times 2 times 3 times 3 times 5. Okay, so GCF in this case would be equal to, let's see, there's a 1 common, there's a 2 common, and then there's a 3 common, another 3 common. So GCF is going to be 1 times 2 times 3 times 3, which is 18. 18 is the GCF. For the next one, GCF, we just talked about the variables. It's going to be every single common variable raised to the lowest exponent. Lowest exponent x is raised to is 1 in here, and y is raised to a second power. So my GCF is xy squared. In the next one, I do have the numbers. I do have the negative sign is not a common in every single term, so that wouldn't come down. But go ahead and do the work for this. For 18, 63, 27, and 9, find the GCF. It's going to be 9. And then the common variable to the lowest exponent is 9y squared. Factoring out the GCF means, this is really important, whenever you see a polynomial that needs to be factored, it says factor the polynomial. That means you pull out the GCF first. That's the first step in factoring. Look for a GCF. Is there a greatest common factor in the polynomial? If there is one, take it out. It is undistributing the GCF and writing the polynomial as a product of GCF and another polynomial. Factor each of the following. So we are going to be factoring this polynomial, y to the 5th minus y to the 7th. So what is the GCF here? Remember, it's only variables. So I'm going to pull out the GCF, which is y to the 7th in these two terms. It's y to the 5th. I apologize. Lowest exponent, y to the 5th. Y to the 5th times what gives you y to the 5th? 1. You need 1 for the placeholder. Y to the 5th times what gives you y to the 7th? It's y to the second power. Okay, next we have, for example, number 2, 6a to the 4th minus 12a, which gives you 6a is my GCF. You can write them separate and go ahead and do the work to find the GCF here. But I already can see that there's 6a is the greatest common factor. 6a times what gives me 6a to the 4th will be a to the 3rd. 6a times what gives me 12a, that would be 2, a cubed minus 2. So 6 times a to the 3rd power minus 2. Example number 3, we have 15x to the 3rd y squared plus 35x squared y squared. What is the greatest common factor? Again, go ahead and you can write the terms separate and find the GCF. I can already see for 15 and 35, greatest common factor will be 5. X to the second power, y to the second power. So factoring out GCF means undistributing the greatest common factor. So we are pulling out a 5x squared y squared. Now when we multiply the GCF back into the polynomial, we should be able to get what we started with. So 5x squared y squared times what gives you 5x to the 3rd y to the second power? It is going to be 3xy. 5x squared y squared times what? Remember, the exponents are going to add up. So x squared times x will be x to the 3rd. Y squared times y will be, there should be no y here. So Yes, that needs to be corrected. There should be no y here, just 3x. Plus 7, x squared is already there and y squared is already there. So it's just 3x plus 7. Okay, 3x plus 7. In the next one, it's a little bit harder to see what is the common factor, but here, common factor is a binomial. You can go ahead and pull out the x plus 2 in there. Inside, you'll be left with 8 minus y. The common factor is x plus 2. If I pull it out, if I undistribute, inside I have 8 minus y. And you can go ahead and try to multiply these back and see you would get what you started with. Next problem, I see a negative sign is common throughout. So that is my common factor. 3 is a common factor. A is a common factor. 3a times, negative 3a times what gives you 9a to the 5th? It's going to be 3a to the 4th. And then plus 6a and plus 1. We need 1 for the placeholder because when we distribute the GCF back, it should be the same polynomial that we started with. Next one, again, I see the common factor is a binomial, so I can pull that out, z squared minus 6 and r plus 1. There's a hidden 1 over here in the front. That is my factored form of this polynomial. You can see we are writing the polynomial as product of two things, product of two things, product of two or more things. That would be factored form. I'm going to leave number 7 and 8 for you to try. Go ahead and try number 7. Pause for a minute. Looks like 1/7 x squared. So 3x squared plus x minus 5 is what I would be left with. 16 and 24, the greatest common factor, looks like it would be 4x to the second power, y to the third power. So that would be 4, no more x's here, 4 minus, nope, 6. 6 times 4 is 24. 4 minus 6, and we already have x squared in the front. We need one more x. We need one more y, and that would give us what we started with, x to the third and y to the fourth. Always check your work. So you can check your work by distributing back. So if I distribute it back, I would be left with 16x squared y to the third minus 24x to the third y to the fourth, and that's what I started with. So I got it correct. Okay, next we will talk about zero product property. Zero product property says if product of two expressions, product of two terms is 0, then one of them must be 0. So it's definitely that either A is 0 or B is 0. If A times B is 0, then either A is 0 or B is 0. One of them must be 0. Okay, so if product of two things is 0, one of them must be 0. Now, this is only true if your right-hand side is 0, okay? If your right-hand side is something else, I'm just going to give you an example, which if you have A times B equals 12, then you cannot say either A is 12 or B is 12 because you have many, many options. A can be 12, B can be 1, A can be 6, B can be 2, A can be 1/3, B can be 36. So there's many possibilities then. So you cannot use zero product property. It only works if your right hand side is 0. Keep in mind, okay? Zero product property. If A times B is 0, then either A is 0 or B is 0. So we want to solve some equations using the zero product property. X times x plus 12 equal to 0. We will also be using the GCF technique that we just talked about. Solve each equation using the using the zero product property. So let's go ahead and use the zero product property here. It says A times B is 0. Either A must be 0 or B must be 0. Either A must be 0 or B must be 0. If A times B is 0, either A is 0 or B is 0. So that means I can say either x is 0 or x is negative 12. So these are my two solutions for this equation. These two solutions will make it equal. My left and right hand side would turn into 0 if that's the case. Okay, next, number 2, we have 2x plus 1 times 2x minus 1 equal to 0. already in the factored form. So I already see the product of two factors is 0. That means I can go ahead and use zero product property, which says either the first factor is 0 or the second factor is 0. So if I go ahead and simplify, solve each of them separately, I'm going to be left with 2x equals -1 and then divide both sides with 2. On the second equation, I'll be left with 2x equals 1 and divide both sides with this was -1. Okay, so there's my two answers, -1/2 and +1/2. Now we got number 3, equation number 3, 2x times x plus 9 times 7x minus 20. So this a times b equals 0 can be extended to more than two factors. If you have a times b times c equals 0, now 3 factors, or even 4 or 5 or 10, then one of them must be 0. Either a is 0 or b is 0 or c is 0. One of them must be 0. Okay, so here we are. Now we have product of 3 factors. And product of 3 factors is 0. That means one of them must be 0. Either 2x is 0 or x plus 9 is 0 or 7x minus 20 is 0. So if product of these 3 expressions is 0, then these 3 binomials, monomials, or these 3 terms is 0, then one of them must be 0. So go ahead and solve each of these individually, and we will have 0 divided by 2 is 0. And from the second equation, I'm getting x equals -9. From the last one, I'm getting x equals 20 over 7. Because we would add 20 to both sides and then divide with 7. So here we are. There's 3 possible answers here. These are the 3 values of x that will make my left-hand side equal to 0. That's what solving an equation means, that your left side and right side are equal to each other. Now let's look at example number 4. It is not in the factored form, so I first need to get it in the factored form. And then maybe I can use the zero product property because right-hand side is 0. So how do I factor it? Let's look for a GCF. Is there a GCF in here? Yeah, there is a, which is the GCF. And inside, I'm left with 4a plus 1 equal to 0. Remember to use 1, don't forget, because you want to have a placeholder here. When you distribute the a back, you want to get your original parentheses back. So this leaves me with, now I have factored form of this polynomial, and product of 2 factors is 0. Now using the zero product property says either a is 0 or 4a plus 1 is 0. When I solve, I am left with negative, either a is 0 or a is -1/4. Okay, that's all we're left with. Here's number 5. What do I do with this? Do not cancel the x's on both sides, because when you cancel the variables on both sides, you lose some solutions. So that's not a good start. First thing, I would bring everything to one side and get a 0 on the right-hand side. So I'm going to add 9x to both sides. X squared plus 9x equal to 0. I really cannot add x squared and 9x because they're not like terms. One has a variable x squared, the other one has an x. Now let's see, it's not in the factored form. I'm going to try to factor it. How do I factor this equation? Will be pulling out the GCF. Is there a GCF in here? Looks like x is the GCF. So inside the parentheses, I'm left with x plus 9 when I pull out the GCF from this left-hand side of the equation. Now right-hand side is 0, so we can use a zero product property, which says either x is 0 or x plus 9 is 0. That gives me either x is 0 or x is -9. There's my 2 possible answers. Both of these answers will make my left-hand side of the equation would turn into equal to the right-hand side of the equation.